Hello, my name is Stephen Nelson. I'm here to present the GTX 2021 competition on evaluating the geothermal development potential in selected oil and gas basins. Here's our outline on our presentation. Moving forward, formation temperature is an important parameter in evaluation of geothermal. It can be used to calculate flow capacity, geothermal gradient, and thermal well potential. Define and identify geothermal prospect wells within Duvernay and Eaglebine by using the machine learning regression models to predict true formation temperature, which is then used to identify geothermal prospects. Machine learning begins with exploration, data analysis, and features engineering. Then we train the model to predict true temperature. Finally, we calculate thermal gradient. EDA is exploring a data set for 821 wells divided among Alberta and Texas. The data contains various features, including bottom hole temperature, formation tops, and many more. Feature engineering is a process of elimination, which we found to be iterative. This also includes dealing with missing values, weighing the number of missing values with the importance of the feature is important. Certain values needed to be computed, such as depth below sea level of the well and depth below ground level of the well, and many more. These became some of our most important features. Removal of outlying data was done. These are our results. There are many insights that result from the exploration data analysis. Predictions of true temperature fall along the target line, and the trend shows that our model is acceptable, with a mean standard error of 4.19 and mean absolute error of 2.94. 36 values were removed due to the predicted true temperature of formation being lower than the bottom hole temperature. This actually reduced noise in our model. Thermal gradient is temperature per meter down the well hole. It is necessary to find and calculate the heat flux, which we assumed a good indicator of thermal potential. Thermal energy potential was calculated by the conduction heat flux equation, resulting in a heat flux being averaged at 1202 watts per meter squared in Duvernay and 947 watts per meter squared in Eaglebine. Other statistical data is also present, which we will talk about next. Max formation temperature is 129 degrees Celsius and 196 degrees Celsius in Duvernay and Eaglebine, respectively. Spatial analysis of Duvernay in Alberta revealed that the highest formation temperature was closer in proximity to the deformation front of the foothills, as seen on the map. While spatial analysis of the Eaglebine in Texas revealed that the highest formation temperatures were closer to the Mexia-Talco fault line, as shown in the map. Apps can be created to predict formation temperature in real time by inputting data into the required features that are ranked most important in the machine learning algorithm. Geothermal power generators include binary, flash steam, and dry steam. Potential uses include power generation, heating buildings, and of course, hot springs. Business cases involve the low cost of geothermal energy with the low environmental impact, which results in carbon reduction incentives for industries, processing, and refinery operations. Environmental impacts are mitigated as it is the cleanest energy production method. However, earthquakes are possible if injecting on a fault zone These can be mitigated using EVOR's Everloop technology. Drilling on fault lines has the best yield in reservoir temperature. Spatial mapping allows business intelligence models to be created for planning. I would wish, of course, that there were no missing data in our data sets to make the best utilization of the features. Eaglebine turned out to have 82 viable wells, while Duvernay had 30 viable wells for geothermal energy production. Thank you very much. Here are my references. Have a good day.